In this video, we're going to be covering 4.2, which is solving quadratic equations by graphing. Before we start, I want to explore this problem. We want to sketch the graph of y equals x squared minus 2x. When we're sketching a graph like that, that's like what we've been working on, we can see that it's in standard form. And since we have a bx, we know we need to find the axis of symmetry first. X equals negative b over 2a. So x is equal to negative 2, so positive 2, over 2 times 1, which is 2. So x is equal to 1. So we know that our axis of symmetry is here at x equals 1. And when we plug that 1 in, we get y equals 1 squared is 1, minus 2 times 1 is 2, which is negative 1. So our vertex is at 1, negative 1. Since this graph is the same as the parent function, the shape is the same as the parent function, we can go ahead and plot a few more points. And we've got a sketch of our graph of y equals x squared minus 2x. Now, when we're looking at these graphs, we want to take a really close look at the x-intercepts. The x-intercepts are where the graph actually touches the x-axis. This has two x-intercepts, one at 0, 0, and one at 2, 0. Sometimes you'll see the x-intercepts written as ordered pairs, or sometimes you'll just see them written like this, 0 and 2. Now let's look at question C. It says, what is the definition of a solution to an equation? Let's get this down. In x. Okay. So the solution to an equation, we know, is the value that you can plug into the equation that makes it true. What does x equal in order for the left side of this equation to equal 0, like the right side? Well, in the last chapter, we learned to solve these by factoring. We look for what do they have in common. These two have an x in common, so I'm going to factor out that common factor. That's the only factoring I can do, so I'm ready to solve. What value of x makes this equal 0? 0. And then what value of x makes x minus 2 0? Positive 2. So these are the two solutions that when I plug them into that original equation, they make it equal 0. For example, 2 squared minus 2 times 2 equals 0. So our solutions are 0 and 2. Now you may notice that those solutions here are the same as the x-intercepts that we got here. And if you compare the two problems, here we were working with y equals x squared minus 2x. And here we're working with 0 equals x squared minus 2x. The only difference here is that instead of a y, we had a 0. That's why on the graph, we're looking at where does y equal 0? Right there on the x-axis. So those 2 points are not only the x-intercepts, they're the solutions, because those are the 2 points where y is equal to 0 on that parabola. So we're going to use these graphs to help us to solve. Okay. Sometimes we can graph by hand when we're graphing these. Something like this is a good example. We see that the graph has been shifted down 4, so we can go down 4. We see that it's the same shape as the parent function, so we can quickly graph a few more points. And we see right there, we have x-intercepts at negative 2 and positive 2. Now remember, when I'm graphing, I'm really graphing x squared minus 4 is equal to y, not is equal to 0. But when I'm looking for my solution, the only piece I'm looking for is right here where y equals 0. So for this equation, x is equal to negative 2 and positive 2. Now if we look at question B, we notice that it's not one where we can see the shift. We'd need to use the axis of symmetry again. X equals negative b over 2a. So we get x equals negative 3 over 2 times 1. So we get x is equal to negative 3 halves. I can tell right there that this is not going to be a really nice problem to graph by hand. And since I have access to a graphing calculator, I would go ahead and grab my graphing calculator I go to the y equals screen and I plug in whatever my equation is, x squared plus 3x. And then I want to go to the graph and look for where does this graph cross the x-axis. It looks like -3 and 0. And so what I can do is go back to my problem and say, if I plug in a -3, -3 squared is 9, plus 3 times -3 minus 9, does that equal 0? And it does. So -3 is one of my solutions. And the other place it looked like it crossed was at 0. So if I plug in a 0 to this original equation, I get 0 squared is 0 plus 3 times 0. Does that equal 0? And it does. So my two solutions are -3 and 0. Now when you're looking at a graph, it won't always be quite so obvious. Sometimes your answers are not going to be nice integers. And so we're going to look at another method for finding those x-intercepts when the numbers aren't quite as nice as they were in this example. So when we're looking at solving by graphing, these are our steps we want to use. We write the equation in standard form first. So you want to have ax squared plus bx plus c equal to 0. If it's not in that form when you start the problem, go ahead and rearrange and do what you need to do to make it equal to 0. Then we're going to replace that 0 with y and graph the related function. And once we have it graphed, we're going to find the x-intercepts. Remember that x-intercepts are also called solutions or roots when you're talking about the equation itself without the y. All right, so what we can do is we can look at these. Already I see that they're kind of, they're not quite as easy to graph as that first one, so I would probably go ahead and take my graphing calculator and solve those, and you can practice right there. Sometimes you're going to be given the graph, and when we look at this, it says find the zeros. So the zeros for the function are the x-intercepts for the graph, and we see this one is hitting at -1 and at +3, so those are the zeros. On this next one, though, you notice it's not crossing at a nice lattice point. It's crossing here and here. So somewhere between -3 and -4, and somewhere between 0 and -1. They want us to approximate these zeros to the nearest tenth. So one of the ways to do that is to take this equation, x squared plus 4x plus 1, and plug some numbers into it. This looks like it might be hitting at about it's between -3.5 and -4, so maybe I would try -3.7, and you can plug that in, 4 times -3.7, and then plus 1, and do that on your calculator. Another thing we can do is actually find the zeros using our calculator. So if we want to do that, we're going to go to y equals, we're going to type in that equation, x squared plus 4x plus 1. X squared plus 4x plus 1. Get rid of the rest of that. Oops, let's just clear the whole thing. X squared this graph looks just like the graph we were looking at, but what we can do with our graphing calculator is actually calculate those x-intercepts. We do that by hitting second, calculate, and we want to find the zeros for this graph, so we're going to choose number 2. The calculator is going to ask you 3 questions, left bound, right bound, and guess, and they're all down there at the bottom. When it asks for a left bound, you need to move to the left. Our x-intercept looks like it's right around there. We want to move to the left of that x-intercept, and then we hit enter. That's choosing the left bound. We don't want the calculator to look any further left than that. Then for a right bound, we move to the right of our x-intercept, and we hit enter. You can see the blue lines are telling the calculator we want it to look in between those 2 points for where does it cross the x-axis. And when it says guess, you're going to hit enter one more time, and it gives us our 0 is about -0.27. It said round to the nearest tenths place, so we're actually going to say about -0.3. So this x-intercept over here is about x equals negative 0.3. Then for this one, we're going to have to do those calculations again using the calculator. We're going to do second trace. We tell it we want to find the zeros. This time we're going to move left. We've got to get over here to this other x-intercept. We're going to move left a little bit for our left bound and hit enter. Right a little bit and hit enter. And then when it asks to guess, we hit enter one more time. If you're getting a message that says error bound, you're missing the x-intercept when you choose your left and right. So be sure you move to the left to get a left bound and to the right to get a right bound. Don't stay right on top of the point. So our other zero is here at about negative 3.7. So those are our two solutions to this. Those are the zeros for our function.